So hi everyone. I don't know if I'm audible. Okay, I can't speak Spanish for life, so I am assuming. Yeah, I'm just so jealous of all of you. I wish I can speak at least 1/10 of what you guys can speak. So bear with me. I can only speak English. So today it's a bit of a detour from what you've heard so far in the whole day. This is not just specific to cloud native. This can apply to your bare metal on-prem, wherever you're deploying your software applications. This framework can be used anywhere. So I just put the title cloud native because it'll make it look relevant. Yeah, so let's get started. So this talk is about, first of all, thank you so much for choosing to show up, because this is the last session and you have a choice to not show up, and I'm very, very grateful for that. And I'm happy that you want to know how to build resilient software systems and why idempotency is important in building systems that are durable, fault tolerant, and resilient in the face of disaster. So this talk is about that. Why is idempotency a crucial element in building software, and why is it not talked about much? It is inherently built in every software you see, but not many people talk about it because it just works. So not much focus is emphasized on it, but not every company is actually doing it. So people who are not doing it are seeing the failures, and error handling is becoming a pain in the pain point for them. So in this talk I'll discuss the general challenges of distributed system, and how there is a software company I work for. I'm not endorsing them, but the tool itself is open source. It's called Temporal.io. It's an open source durable execution engine, and I'm just going to briefly touch upon how it will help you build systems that are idempotent, resilient, and also deterministic. That's what you're going to learn from this session. So it will simplify developers' life so that they don't have to keep the lights on and just keep checking for the errors and how to handle them. So this framework will make sure that it is built for positive results always. You will assume that everything will run, everything will work. So yeah. A bit about myself. My name, I'm Geetha, and I came from California. I'm originally from India, but I've been living in the US for 15 years. So that's like my second home now. I live in the Valley. I worked for a few companies as a software engineer before I transitioned into a customer-facing architect role at these companies. Fittingly, all these companies are open source companies. So I worked for a bit at Cloudera, which is Hadoop-backed Confluent. I was a contributor for Kafka, so I spent some time at Confluent. And then I moved to Elasticsearch. I was there for 1.5 years. And I recently left Elastic and I joined really small company called Temporal. Yeah, that's my journey so far. That is my Twitter if anyone wants to follow. So what is idempotency? How do I go back? So what is idempotency, right? If you brush back your fundamentals from mathematics days, idempotency is basically this, like you give input, you write a function, you give an input, and then you expect an output, and that's it. And when you give multiple inputs of the same type, the operation shouldn't result in a different output. It should be the same. That is basically idempotency. As on the screen you can see, it can be, the function can be executed several times, but that doesn't change the final result beyond the first operation, that is in the first run. Whatever you saw in the first run, it will be the same in every consecutive run. You should see the same result. You shouldn't see any different outcome because the input has changed. I'll give you real world examples so that you can relate what I'm exactly trying to tell. So, but as software engineers, you will want to make sure that when the user is sending a request to the server, and then if the request is coming in once, twice, and multiple times, and the intended result is anyway achieved. You write a logic, hit the server, get this result, you get the result. But if the server is hit by the same request multiple times, you should not be giving, the server should be inherently handling that intelligently, that it should not return a response that is different from the first response. It should be the same response or no response. That should be, that is how an idempotent system should be. And in real world, all systems are idempotent. If it is not, then it is not a reliable system. That's why you see these things like ordering system, right? Let's say you ordered some item on eBay or Amazon, and then with some order ID. And if imagine it's not realistic, but let's say with the same order ID, another order comes in. If the system is processing it, then there's something wrong with the code, because it should not accept. It's basically a duplicate, because there's a key that's identifying that order, and that particular order with the same order ID should never be processed again. So this is how modern day reliable distributed systems are built. And we'll never know about it, because it's just a given that it will work. All the orders will go through, because all orders are unique, all our order IDs are unique, and it will never happen. But there will be cases like in social media, sometimes a message will be sent twice, and duplication happens a lot. So how do you deal with those such kind of situations is where idempotency will become crucial.
Greta, just try to put more
closer. Yeah,
yeah, to
sure.
Test with her with the. It's okay.
Yeah. I'm also my voice is like really very low. I'm inherently built to speak very low, so I've been given this feedback, so I won't get offended. So yeah, why is idempotency paramount? Just some basic background here. So we want the data to be consistent. So because when you're doing a distributed system, there are these different servers. You want to have a synchronized state of all these servers having the similar state, right? So idempotent operations, they offer a safety net by allowing you to retry an action for you without worrying about anything causing a data inconsistency. If a system is idempotent, it will make sure that it will have an inbuilt retry mechanism that will make sure that that particular transaction is finished, and then there is no duplicate transaction coming in. Fault tolerant, because idempotency will guarantee fault tolerance, you will see a system that's inevitably, because systems are meant to be crashed, like networks will fail, databases will crash, and all kinds of errors are meant to happen, right? So when that happens, like idempotency plays a pivotal role by making sure that during this error is happening, the fundamental function is retried, and that the state is appropriately maintained. And retry mechanisms is a crucial element of idempotency, meaning like software engineers can design systems to automatically retry failed requests, and they don't have to worry about the side effects. So it simplifies the code base and reduces the complexity of handling various error scenarios. All I'm trying to tell is when you build an idempotent system, it has inbuilt retry mechanisms so that it will make sure that for a given input, an output is a desired output comes out. If it doesn't come, it will retry. If a different input comes in for the same kind of, if a different request comes for the same function, it won't process. It will reject that particular transaction. That is how a fault-tolerant, idempotent app is meant to do. If you see in the screen the example of how life of a software engineer will be without idempotency, where let's say you submit an order with an ID 1234, and the system is not idempotent, the processing is done non-idempotent fashion, you will see that the order is shipped for the customer already, And by mistake, if the order ID is, the same order ID is given, and then this system without idempotency will ship the order customer the same order again. We probably saw this kind of situation before, that you received item twice and you wonder why, because this happens also in real life. Maybe the system was not idempotent. And if there is idempotency, the processor is inbuilt to deal with duplicate orders, and then it will reject the duplicate transactions. These are implementation details that I have not included in this session, but you can always reach out to me and I'll tell you how Temporal is doing it. One more example is a messaging queue or a Kafka or any event bus, where publisher or a producer is producing data to a queue or a Kafka topic, and then there is no, let's say there's no acknowledgement from the topic. Then the producer wouldn't know if the message was sent or not, because the acknowledgement failed. Oh, sorry, I'm not sharing. Yeah, so in this case, the producer is sending a message to the, I'm assuming you all know the semantics of message buffer, where there's a producer, there's a consumer, and there's a messaging buffer or a queue that will broker the message transition. So when the message is sent and then the acknowledgement doesn't come back to the producer, it will inherently assume that, okay, the message is not sent. So it will send a message again. And if the system is idempotent, it will handle these kind of API caller errors by simply retrying. And similarly, if the message handler is idempotent, it will allow an at least once delivery mechanism, meaning there will be a chance of duplicate messages, but at least the end application will be guaranteed that at least once the message is transmitted. So this is one real world example where idempotency is included. And now I want to give you a real world example of what idempotency means in just apples to apples comparison. So imagine in a simple real life where there's a media player app, and let's say you're playing music in that app, and you tap the stop button, the player will simply stop, right? And then now the player is not playing, the stop button is pressed, and you press the stop button again. What happens? It'll still keep stopping. Nothing really happens because you keep pressing the stop button, nothing progresses, the stop state is saved and it will stay in the stop state forever. That kind of system is idempotent, because how many number of times you give the input, the output is not changing. That is idempotency. Now imagine a situation where in the same app there is a pause and play button. If you tap in the media app when the media starts, and then you tap it, you tap the play button, it plays, and then you tap the same play button again. It pauses after that. There's a pause and play, right? In this case, the play and pause button, it's not giving the same result every time you press it, even though it's the same button doing multiple functionality. So this kind of system is not idempotent, because for the same input, there are different outputs. The button is designed to be multifaceted. Even though the interface is showing you that it's the same function, it's not exactly the same. So that is not idempotent. You hit the same button for playing and pausing, but the output is either playing a media or pausing a media, as opposed to the stop button that we use in the same app. This is just one example to show you how systems should be built to make sure that the software stays reliable and that you don't have multiple outputs for the same input. Now, taking a step back, I've just spent some time on idempotency as a concept. I wanted to talk a bit about how event-driven systems are built and how it has become a paradigm now. Every company has accepted that they have to be event-driven. That is great. Event-driven is awesome because it's loosely coupled. It makes your applications just be independent. Everything works. You have these consumers and producers, all these downstream apps that are independent. It works until it won't, right? If something breaks, that's when you'll see the need for a single pane of a glass or a single platform that can deal with all these breakpoints, or where you see a database crashing or a API going down or a orchestration of between these microservices is failing. Something like this will come into play, and then you'll realize the need for a centralized platform that will make sure that all of these are kept in check. This is a background I'm giving to introduce you to Temporal, which is a company I work for. So I also work in sales, so I'm not selling this, but I'm just telling you what I would tell to my customer. So what is the desired goal of any reliable system, right? You want to make sure that there is high development velocity, and then you don't want it to be complex. The system should be less complex, but there is high developer velocity. The developers have to actually enjoy building things that are complex. But in real world, as complexity increases, the velocity and reliability usually suffers, and that can be detrimental to any business. So what happens is that you are not really doing a good job in maintaining a balance between those two. Now what you need is something called as temporal, which will give you durable execution, simplifying your apps, making them more reliable, and then making sure that you deliver the features faster. So what is durable execution? This is nothing new. All the engineers have been doing it for many, many years, but this is a new wave or a new abstraction for developers to modularize their code so that things are achieved easily with less number of lines of code, and then more organized fashion of flow between your functions and your business logic. So yeah, so this is basically one way to write code, make it fault tolerant, and then eliminate the complex plumbing and error logic writing. So this temporal will basically give you a new abstraction for developers that will fundamentally change the way you build and deploy functions, deploy code, and build event-driven architecture. So let's take an example of a simple money transfer flow, right? This is a code that you would normally write, where first there's a small method that will talk about how to withdraw the money, and then the next method that will deposit the money into the in the recipient's account. Yeah, so you basically have that, which will basically withdraw, and then the next one will basically deposit. But that's not exactly how always it happens, right? So now once the user has withdrawn the money, the app has processed that API call, and then we are waiting on that blocking call, and the process really crashes at the deposit at the deposit method, right? So and what happens then? What do we ask ourselves? We think like what state are we in? Like, did the deposit really happen, or did it not happen? In a normal world, we would have to have a plan for this. Like, you really have to have a error handling logic that will say, like, if the process fails or crashes at this point, do this. That sort of error try catch or some kind of error handling logic you have to put in there. That's on the developer's side to make this happen, and the code to interrupt and fix the issue is on the developer. But with durable execution, what this platform does is it captures the state and the functions and the variables and what's going on in this whole process, and then it will make sure that the developer has to write the code basically, but when they write the code, they write it in a non-blocking fashion, meaning which the server which is crashed will be moved on to, transitioned or graduated to another server, and then because the state is already saved in the form of a workflow, this new server will rehydrate the state from the workflow, which is the event history. There is a jargon for this whole platform, but yeah, the event history saves the state of this particular process. The new server will read the state from that event history and then rehydrates and then continues as if nothing has happened. What developers are getting is that they will save their time and energy in trying to think about error scenarios and handling them in the code. So in this case, because Temporal is built to always give you positive results and assume that nothing will fail, the response comes from the gateway and the function can now just carry on this new server. So yeah, that is Temporal for you. It's an open source program. The beauty is that you can always go try this out on the temporal.io. You can check out how that works. There is a paradigm, there is a framework that you need to, there's a slight learning curve, but not so much if you are a native programmer in any of these Java, Python, Go, or PHP, basically any language under the sun. You can start writing code in Temporal. So some of the Temporal capabilities are, we talked about saving the state. There is retries that are inherently put in so that when a function is failing, it will retry unlimited number of times. You can also configure the maximum number of attempts a function will run so that the code is not failing. There are timeouts and timers that you can put in your code conditionally. There are basically everything we do in life in system engineering is a workflow, right? If this happens, do this. If this happens, don't do that. So it's always a decision-making process in every step of the way in system engineering. So where you need timeouts and retries and timers, and because Temporal is built in with all these functionalities and libraries, you can just use it out of the box. And it blends into your SDKs really well, so you don't have to really learn anything new. You can schedule some things for you from programmatically, also from API, also from CLI, and then make sure that your workflow runs without failure. And then there are these, so security. These are basically the features of Temporal Cloud, which is a managed offering. So I don't want to talk about that. But if you're interested, check out the Temporal Cloud as well. It has many features that the open source doesn't offer, which is built-in security model, data encryption, like there are codec servers you can write and put into your using your SDK that Temporal provides, and then make sure that the data is encrypted with your own keys and that the cloud is not actually able to access any of your data that you are sending to Temporal Cloud. That's not relevant, but yeah, if you want to try, it's just easy. They also give you $500 credit for your first trial account. So yeah, check if you're interested. So how does it work? How does Temporal really work, right? So it's very easy. They call it a workflow. Whatever business logic you're implementing is written in the form of a workflow. Business logic here can be anything, your ETL pipeline, your order processing system, or in the inventory space. If you have a HR-based system, if you're approving some time offs, that can be a workflow. In your data space, if you are building a pipeline, moving data from, let's say, point A to point B, and there are multiple hops that data is doing, that can also be a workflow. So basically anything and everything can be a workflow. So that is business logic that you want to achieve. That business logic goes into a workflow. And there are semantics. You have to define methods and other interfaces. If you are a programmer, you know what I'm talking. So you have to follow certain rules that are set by Temporal. And it's very easy. It's just they are built into your SDKs, Java or whatnot. And then you'll have to follow the primitives that are set by Temporal, which is in this case, all the business logic stays in workflows, and then all the functionality that is inherently set to fail is put in activities. Meaning, let's say in the money transfer app, when you're transferring money from person A to person B's account, if let's say there is a failure scenario like, let's say API is down or something like that, and then after a certain amount of time, the deposit shouldn't happen. If that is if that is the intended output, you can write that in the form of an activity, and the activity will try to retry infinite number of times. You can also set the maximum number of times an activity can retry, so that it stops after a certain time and it fails the workflow, and the transfer will not happen. So yeah, there are nuances around it and other logic you can write, but basically what I'm trying to tell is your core logic will go into the activities, which are basically methods, and then the whole business logic will go into workflow. After you define your activities and workflows, you deploy your application into a temporal worker. So worker will run the application and plays a crucial role in automating the whole capturing the state scenario. Workers are something you run. You are capable, like you will be in charge of running the workers. Workers are basically nothing but your Kubernetes pods, or it can be virtual machines or real machines in your data center. It can be, that's where the code runs basically. Wherever if it's on your laptop is a worker. If you have a Kubernetes cluster that has 10 pods, that is the worker cluster. So that cluster will send signals to the temporal server, which can be either maintained by the company Temporal, or you can self-manage that temporal server, and server will receive signals from worker. Worker will also send the state to the server. Server will save the state. In the face of disaster, workers will pull the latest state and then try to restart from where it left off and before the disaster happened. Yeah, that's basically it. Why I'm telling all this is idempotency is important, and Temporal does it this way. I'm just introducing you to the primitives of how things are done, so that when you're writing idempotent code, you will know the basics of it. Yeah, so the worker does two things. One is capturing the state, and then sending it to the temporal server, and then it also continuously polls the server for the tasks that it needs to execute. Let's say there are multiple commands that you have to run in a function. Every command is translated into a task by the temporal server, and then worker will poll for that task. It will wait for temporal server to tell, go do this, and it will do it. And after done, it will send back the signal saying, okay, I'm done doing it. I'll sit idle until my next task comes in. That's how things work. And then, yeah, worker is basically something you have full control of, where your code is running, and that's it. And how do you do idempotency with Temporal is, you can write a method which is basically an activity which repeats and then achieves the same result every single time you run that method. Which is recommended that you use activities for writing idempotent code and not workflows, so that if failure happens, there are retries possible. Because in workflow, there are no retries. You cannot retry if a workflow fails. There is a special facility where you can write a retry mechanism for a workflow, but that's for edge cases, like really not out of the box. So yeah, anything that's prone to failure is put in activities, and that is made idempotent. Yeah, so how does idempotency work is, it's just by basically using an idempotent key. So to be able to distinguish a duplicate operation, like an API call or event coming in, we need something like an idempotent key that will typically be a combination of like a request ID or a resource ID, something like that, based on your application. And then with Temporal, it's the same. You will define a idempotency key within your application, and then you will tell the activity to read the events based on that particular ID, and then mark it as at least once done, so that you are not reprocessing it again. Once processed, don't process it again is what it will do. And you can also set maximum number of attempts. That will make sure that if you put the maximum number of attempts to 1, it will ensure that you're only doing it once and that there's no duplicacy. Yeah, so that's it. I'm done. So yeah, for example, you take this code, it's in this case, if the external API dot submit order, if it doesn't do anything when it is receiving a duplicate order IDs, meaning if the first thing it attempts is, if whatever it's doing the first time is inserting a record into database with a uniqueness which has a uniqueness constraint on the order ID. So no database data will be changed, right? So it will just return an error. Then the order ID will serve as an idempotent key. So basically, if one element is treated as an idempotent key, that will never allow duplicate things to happen. So yeah, that's what I'm trying to tell in this case. Yeah, so that's a bit about like idempotency keys and how to achieve it using temporal. I know this is a very niche concept. Only now companies are adopting it. So if you have questions, reach out to me. There are some resources I linked, how to start off with temporal, how to define activities. It's an incredible platform. I'm not saying this because I work for the company, but I've seen customers like Netflix, all the big names like Tesla. I'm revealing some names. These are public names anyway. Snap and big companies adopt this framework. They started off open source and now they're moving into the managed offering because the scale is really big. It is doing wonders for when you need error handling to be automated, or failure scenarios, or building reliable systems. If it's your thing, you should definitely consider temporal and idempotency. Thank you so much for this opportunity. I don't know if I did it. Yeah, I don't know how to.